Hi guys, Dr. Justin Sarvi here, going through your second semester test, and I'm looking now at question 7, where you're asked to consider the function f of x is equal to sine x over the absolute value of x. Now, as soon as you see the absolute value sign, you should be thinking to yourself piecewise definition, and in fact what we're going to do is we're going to write out the pieces of this function. Now, the second thing to note is that here we've got the absolute value of x in the denominator. Now, the absolute value of 0 is just 0. So when x is equal to 0, we've got a division by 0, and that makes something undefined. So this function is not defined when x is equal to 0. So when we're doing our pieces, we usually have when x is greater than or equal to 0. But because x is not allowed to be equal to 0, we're going to have just when x is greater than 0. And of course, we're going to have our other piece when x is less than 0. Okay, when x is greater than 0, we simply remove the absolute value signs. So in that case, the piece is simply sine of x over x. And when x is less than 0, we've got to make the x negative and remove the absolute value signs. So we have negative x in the denominator. And I'm just going to move that to the numerator. So we have negative sine of x over x. And that there is our piecewise defined function. That makes answering the next few questions a little bit easier. Alright, so 7.1, we're asked to calculate the limit as x approaches 0 from the positive side of f of x. So this limit here, as x approaches 0 from the positive side of f of x, well, that's simply equal to the limit as x approaches 0 from the positive side, and we're looking at the function on the positive side of 0. So what does the function look like on the positive side of 0? Well, it simply looks like this. So this is simply the limit of sine of x over x. And you know, as x approaches 0, that this function approaches 1. That's one of the special limits that you needed to learn. All right, 7.2, you're asked to calculate the limit as x approaches 0 from the negative side of f of x, and that's equal to the limit as x approaches 0 from the negative side. Now we need to know what does this function look like from the negative side of 0. Go back to our piecewise definition. When x is to the left of 0, or to the negative side of 0, it looks like this. So we're looking for the limit as x approaches 0 from the negative side of minus sine of x over x. And of course, that's equal to, we can take the minus outside the limit. So it's a nice continuous function of sine of x over x. And now, of course, as x approaches 0, sine of x over x again approaches 1. And in this case, we've got the minus in front, so it's equal to minus 1. The last question here, you are asked if f of x is continuous at 0, and to give a reason for your answer. Well, it's certainly not continuous at 0, and you could have given one of two reasons. The first is, of course, that x is not f of x is not even defined when x is equal to 0. So f of 0 is not defined, and there are three things that you need for a function to be continuous. You need it to be defined at that point, number one. Number two is you need the limit to exist. In other words, the limit from the left-hand and the right-hand side must be the same. In this case, they're different, so that could have been another reason. And your third reason would need to be, for continuity, that the limit, if it existed, was equal to the definition of the function at that point. But of course, this fails on so many reasons for continuity. The easiest, of course, though, is simply to say that f of 0 is not defined, and therefore it can't possibly be continuous at that point.